Hi, this is Mr. Manley. This is a video on transformations. Transformations can be a shift, and the shift could be vertical or horizontal. Transformations can be reflections, and transformations can be non-rigid. And a non-rigid transformation could be a stretch of the function, or it could be a shrink of the function. In this video, we're going to focus on the shift and the reflection, and we'll take the non-rigid transformations in another video. The shift of a function, and the two types of functions that we're going to be looking at are the quadratic function or a parabola, and we're also going to be looking at a absolute value function. All right, and hopefully you know that a quadratic function is, again, the parabola or that type of U shape, and almost similarly the absolute value function is kind of the same, but it's straight. Those are straight lines. It's not U-shaped. I guess you might call that V-shaped. And what we're going to do is we're going to look at starting with the base function, also called the parent function. So this would be the parent function or the base function, what we are starting with, and altering that in order to shift it. So for instance, this f of x squared here that's f of x squared. F of x equals x squared. Shifting that up would simply be adding to x squared. So this is going to be up if it's positive, or down if it's negative. So for instance, with this function here, now we're going to ignore this piece of it here, this minus 2. So we're just looking at x squared minus 3 at this point. And it's negative, minus 3, so it's going to be down. So right now, I would take the graph that I have, and I'd go, now notice this as this goes, I have the origin, and then I'm up 1 over 1, and I'm over 2 and up 4. And that's just if you looked at the points on the graph of a parabola. You would have 0, 0, you would have 1, 1, and you would have 2, 4, right? And then we would have the reflection of those points as well, right? Because of the symmetry of the parabola. So we want to hold on to that shape as we move it. I don't want to get careless with the shape. So I'm going to move everything down 3. So this is the vertex down to negative 3, and then I'm up 1 over 1, and then I'm over 2 and up 4. And I'll reflect those points for the symmetry. Now, of course, if you were doing this on Alex, you're just going to be able to drag the function down. You're going to be able to drag the parabola down. But if we're doing it on paper, which you will need to be able to do at some point, you gotta keep those points. Right, so this is the minus 3. That took into account the minus 3. I shifted it down 3 units. Now if I take f of x and I put the plus c here, so notice the difference in position where I put the c. Definitely a difference there. In that case, this would be positive is to the left and negative is to the right. You take a look at that and think that that might be opposite of what you would think. Maybe you want to say positive goes to the right and negative goes to the left, but not in this case. So I'm gonna now I'm gonna take what I've already done and I'm gonna really begin with the vertex, and I'm gonna move it. What does this -2 say? It's here with the x, and it's negative, so it's 2 to the right. So I'm going to take everything and move it 2 to the right. 2, and then remember, over 1, up 1, over 2, up 4. And do the symmetry of that. Now I can do a solid line because I'm done. That's the last transformation. There. There. And that is a, so we did a vertical and a horizontal transformation there. Here we're going to go the other way. We're going to find out what the equation is. In the previous example, we looked at what is the graph. In this one, we want to take the graph and look at what the equation is. So this is saying, if you take time to read this, if you need to pause it and read it, you can try that. And what this is saying is f of x is equal to the absolute value of x is my initial function. And that's this one here. So I'm given that. That is f of x. We'll say that that is f of x. And it's the absolute value of x. And then based upon that, if that's the absolute, if f of x is the absolute value of x, and I move that function over here, and I call it g of x, that's going to be g of x, then what is the equation for g of x? So I'm going to say g of x is equal to, well, it's an absolute value function, right? So it's an absolute value of x, but f of x is the absolute value of x, that base function, the black one. And what happened? That got shifted this way. Well, let's do the up and down first. So it got shifted down this way. So it got shifted down there. I guess I can just do the down part. Down. And how many units down did that get shifted? Looks like it got shifted 3 units down. So g of x is equal to absolute value of x and then down 3. So that's -3. But then it also got shifted to the left. So it went over this way to the left. And how many units? It went 4 units to the left. And where does that? That is going to go in here with the x. The left-right shift goes with the x. You can look at the previous, look at your notes at this point, and you should be able to see that. So I need to add or subtract, and again, think about that, or look at your notes. See if you can look at your notes and see, predict what's going to happen here. Since it went to the left, I'm going to go +4, because that moves me to the left. The +4 moves me to the left, and then I'm going to keep the -3 that I had there. Okay? So that is the vertical shift here. And I said I was going to do reflections, but I'd like to keep these videos to about 10 to 12 minutes if I can. So I am going to go ahead and end on that thought with the shift, and you can watch a different video to get reflections, and then of course we'll have a third video for the non-rigid transformations.